pressure is given by the formula. Pressure is given by the formula force over area. So the necessary conditions to obtain the correct answer was we should be using force in Newton. So force should be measured or used in Newton, and area should be measured in meter square. So for most of the time, if you are given area in centimeter square, or if you are given some area as centimeters, so you need to convert that centimeter square to meter square. And the conversion method we had seen that 1 centimeter square is equal to 1 over 10,000 meter square, which we also wrote as something 10 to the power negative 4 meter square. Got it? So in this way, you can convert the area from centimeter square to meter square. So am I audible to everyone? Just confirm everyone. Am I audible to everyone?
Yes,
Yes,
sir.
sir.
Yes,
Sir, I
sir.
have one doubt.
Yes, sir.
Yes. What is your doubt?
Sir, it is said that as the depth of the sea, like as we go into the depth of the sea, the pressure
Hmm.
increases. Why does it increase?
Yeah. Okay. So if you remember, we had done one activity of a water bottle. Okay, the similar activity with a water bottle like this. So just remember this activity and your answer will be clear. Okay.
Sir, could you
So,
explain, sir, what were you saying?
yeah, here we had done an activity of water bottle, and in this water bottle we had made two holes at different levels. One hole was at a higher level, the other hole was at a
About
lower level.
fluid pressure, right, sir?
Yeah, about the fluid pressure. Yes. So we observed that water from the bottom level, it comes faster. So from here, the water comes faster, and from here, the water comes slower. Got it? So why? The reason is that at this point, we have a high pressure. At this point, the pressure is high, and at this point, the pressure is low. The reason, above this surface, you have a very small amount of water, but above this surface, you have a large amount of water. Hence, the pressure at the bottom will be higher. So similarly, if you talk about the oceans, so if you go deep inside the ocean, you have this ocean, and as you go deeper and deeper, so as you go deep, the amount of water above you, suppose if you are standing here, you are standing here. So at these two positions, at this position A and the position B. So at position A, you are carrying only this much of water on your head. At position B, you are carrying a larger amount of water on your head. Right? The height of the water which you are carrying is still more. So in which case will there be more pressure? At
B, sir.
height A, at A or at B?
B, sir.
Yeah, at B. And that is
B,
the
sir.
reason. That is the reason if you go deep inside the ocean, you will experience high pressure.
So, sir, it is like the amount of
Yeah,
weight of the water.
yeah, it is the weight of the water which you are carrying. Okay. Now, the same thing happened. One of the expeditions was carried out, and it failed. You heard it was all in news that many people died. There were about 7 to 8 rich people who were going to see the Titanic. Do you remember? It was in recent year only.
Like they went in a cube, sir, like a type of small submarine.
No,
Sir,
yeah, they went in a submarine, and the submarine coalesced.
sir,
It
what
collapsed.
actually happened in the Titanic means
So
attack?
what happened in the Titanic? I'm not explaining Titanic. What happened in the recent past, recent year, that there were a few people, around 7 to 8 people were there who were going to see the Titanic, which is there deep inside the ocean. So they were planning to go inside a submarine to that place. So when they went over there, so due to the high pressure of the sea level, the submarine imploded. Okay, it did not explode, it imploded. Implode means you had your submarine something like this. This was the submarine, and due to the pressure of water from all the sides, pressure from here, pressure from here. So due to the increased pressure of water from all the sides, the submarine imploded. It collapsed. So the death they suffered is something like someone squeezed them out into the submarine.
So type of crushed it.
Yeah, it was crushed. They were all coalesced inside it. Understood, everyone? So shall we
Yes.
move ahead now to the atmospheric pressure?
Sir, so water came inside the submarine due to
Mm-hmm.
the pressure.
No,
Sir, so
water didn't.
most of the submarines travel at a depth like where no increased pressure is there and the submarines can handle it.
Yeah, they travel at a depth where they can handle it. Okay, if they
Sir,
try
like
to go,
the more deep in the like in the fluid, in the liquid,
Hmm.
more the deeper, more the pressure, right, sir?
Yeah, more the deeper, more the pressure. Actually, the formula for the pressure is H rho G. The pressure for the fluids is given by the formula H rho G, where H represents the depth of the fluid, rho represents the density of fluid, and G is the gravity. Okay, which
Okay,
we
sir.
take gravity as 10. Understood this? Okay. Now I think it will be easy for you to understand atmospheric pressure also. Just like water exerts a pressure on the substances, the weight of the water is exerting a pressure. In the similar way, the air column around us. Around us, we have the atmosphere, and see, so on the earth, we are on our earth where we are surrounded by an atmosphere. So the atmosphere is the one which has a lot of air around, air inside. So atmosphere, it carries air. Therefore, so air is there everywhere in the atmosphere. Now, due to the weight of air, okay, so due to the weight of air on our body, it is something like that. It is something like we are always submerged in a fluid of air. When we are residing here on the surface of earth, so it seems we are always submerged inside this air. Are we always submerged inside air?
Yes, sir.
Yes. So
Yes,
on the
sir.
Yes, sir.
surface of the earth, the weight of air, whatever air is above it, so just like we observed in the case of ocean, a similar thing happens over there on the surface of earth. Here you have the height of this. Due to the weight of air, we have a lot of weight of, yeah.
Sir, but
So this
air
is
is
the,
weightless. Sir, but air is weightless, right, sir?
yeah.
Air is weightless, right, sir?
Okay, air is weightless. Who told you air is weightless? Air is not weightless. Air has a weight. Air is matter. Air has mass. Air occupies space. Air has volume. Got it? So air occupies space. Don't take that air is weightless. Air is not weightless. Air has
So,
mass. Hmm?
do we have any formula to find the means mass and weight of the air molecules?
Okay, if you just want to measure mass or weight of air, if
Sir,
suppose you
I
want to
have a
find,
doubt.
yes,
Sir, basically, water vapor is lighter than ice or water, right?
yes.
No, I mean anything in its gaseous form is lighter than its liquid and solid form, right?
Yeah, the density. The density is less. If it is in the gaseous form, it has a lesser density.
Sir, I
Okay.
have a doubt, sir.
Hmm.
Sir, I didn't understood like when we will flip the glass and when we flip the glass on a cardboard or a plate, then
Hmm.
then the water won't come out. Like how the air stops the water from coming out. I didn't understood that.
Okay, see. So the concept, first of all, let us understand what is atmospheric pressure, and then I will come to your question. So there was one of the doubt how to find out the mass and weight of air. Definitely you can. You just take a balloon. Okay. You take a balloon, find its weight. Okay. Then inflate the balloon or fill the balloon with air and now find its weight. So once you inflate it, then after that again find its weight. So here also you find the weight. Let us say here you find the weight W1. Here you find the weight W2. The difference of the two weights will give you the weight of air. Got it?
Sir, in
So
the
there,
way,
yes,
sir, in the second balloon, what should we fill, sir?
you fill air.
Okay, sir. In the first balloon, we have to fill the water.
No, nothing.
Okay, sir.
Nothing is filled in the first one. It's empty. So first you have taken an empty balloon and then you have taken an inflated balloon. Find the difference of weight. So it will give you the weight of air. Okay. So here the weight of air above us, since every time we are carrying air above us, it is like we are dipped in air. So the height of air, it pushes, it is carrying a weight above us. So due to this weight, we will experience a pressure at the surface of the earth. But so this pressure will be equal to the weight of air, and the weight of air will be called as the force. Since it is the weight of air which is exerting the force, so force, which we also call as the weight of air divided by area, divided by 1 meter. So amount of the weight of air per unit area will be the atmospheric pressure. Got it? And the atmospheric pressure is roughly equal to 1 lakh Pascal. It is 1 lakh pascals. The pressure due to the atmosphere is about 10,000 Pascal, which we call as 1 atmosphere. So now I think everyone has understood about the atmospheric pressure.
Yes, sir.
Okay. One more thing. See, atmospheric pressure or pressure acts in all the directions.
Sir, can you explain the balloon part and how to find the air pressure, atmospheric pressure?
How to find the atmospheric pressure, right?
Yes, sir. And the balloons, you have drawn that part also.
Through the balloon, you can measure just any amount of weight of the air. You can measure the weight of air of any amount.
Okay, sir.
Okay. It's not that you are going to measure the weight of all air molecules. Some amount of air has been weighed.
Okay, sir. Can you explain
Hmm?
how to find the atmospheric pressure? Like the P is equal to F by A, that formula.
Yeah. So see, now to find out this using this formula F by A, this was quite difficult. So scientists developed another method for the fluids. For the fluids, the pressure was given by H rho G. Okay. Where H represents the height of the fluid, rho represents the density, and G represents the gravity. So just I discussed here also that the pressure exerted by the fluids is given by the formula H rho G. Okay. Since air is also a fluid, so for air also we use this formula. Pressure is equal to H rho G, where H represents the height of this atmosphere, Rho represents density and G represents gravity. But still there are other experiments by which we can measure the atmospheric pressure. Before that, also remember, just here I told everyone that pressure acts in all directions. Or you can say fluids exert equal pressure in all directions. This is something new for you, that fluids, they exert pressure in all directions which is equal. Okay. Now let us see for this one. Okay. So what happens to measure atmospheric pressure? We have a mercury barometer. So let us see how does a barometer works. I'll show you a mercury barometer which is used to measure the atmospheric pressure. Okay. This is how a mercury barometer works. This is a general experimental look to understand, and this is the actual apparatus. If you observe this one, so this one is an actual apparatus which represents or which shows a mercury barometer to measure the atmospheric pressure. Okay, so you can use this mercury barometer to measure atmospheric pressure, and how it works you can understand over here how the mercury barometer works. Okay. So see the way a mercury barometer works. Now see how does it work. See, inside this tube, you have this column which is 1 meter long. This column of mercury, it is 1 meter long. We take a 1 meter long tube, and in this 1 meter long tube, we fill it with mercury. So this whole 1 meter long tube is filled with mercury. And now how it works? You invert this tube and invert this and dip inside a tub containing mercury. So this is a tub which contains mercury, and this tub is exposed to air. Okay, so see how it works. When it is placed here, the air around us, or due to the atmospheric pressure, this mercury is pushed upward. The mercury over here, it is pushed downward, and hence there is no space for this mercury to go. So therefore, this mercury has just the space inside this tube. So mercury can rise up. That is the only space available for this mercury to go. Are you getting, everyone?
Yes, sir.
Yes.
Yes. So air from the top is pushing this mercury in the tub to go up inside this tube. Okay. When the height of the mercury in this tube increases, so its weight also increases. The weight of mercury inside the tube also increases. See, when air will push it downward, so mercury rises up. Okay, as the mercury rises up, its weight increases. The quantity of mercury in this tube increases, so its weight increases. At a certain height, what will happen? The force exerted by the air and the weight of the gravity of mercury, both of them will be equal to each other. And when both the forces, they are equal to each other, that is the atmospheric pressure, or that height will represent the atmospheric pressure in centimeters of mercury or millimeter of mercury. So here the atmospheric pressure, one atmosphere or atmospheric pressure is equal to 76 centimeter of mercury, or it is, we can also call it 760 millimeter of mercury. That means the mercury will be pushed to a height of 760 millimeter only, or 76 centimeter. Now, if the pressure increases, so this will rise up. The mercury will rise up. If the pressure decreases, so the mercury will fall down. Okay. So
Sir, can you
understood how
even
will,
take the examples of thermometer? Thermometer also has a mercury in it, that's it.
yeah, thermometer also has a mercury, but the working principles are different.
Okay, sir.
Okay. Here you can also use a water barometer.
So there will be a scale on the like on the rod.
Yeah, there will be a scale on the rod which will show you that how much high the mercury has risen up.
Sir, can you please show a picture of water barometer too?
Yeah, what happened? Water barometer, yes. You can also use a water barometer, but there is a problem with water barometer. Okay. The problem is that this, you need a water barometer which should be about 10-meter long. A water barometer has to be about 10-meter long, whereas this mercury barometer is only 1-meter long. So which one will be easy to use?
Mercury barometer, sir.
Okay. So it's convenient to use a mercury barometer than to use a water barometer. Right? Got it, everyone?
Yes.
Yes, sir.
Okay. So understood how the atmospheric pressure is measured, how the atmospheric pressure is exerted. Okay. We had one of the doubts of someone was calling about the inverted glass setup. Okay, who had the doubt regarding the inverted glass? Yes, anyone?
Last year, sir.
Okay, last year. So I'm just taking the diagram for you and then explain. Okay. Okay. So not only a glass, there are different other setups from which the water will not fall. Okay. So water not falling from inverted glass, or you have different other things I will tell you which are based on the same thing. This one you are talking of? Yes. You have water in a glass, and if you suddenly, if you remove the paper, swipe the paper from there, so the water will not fall off. Got it? This was your doubt last year? See, last year I had the doubt that if you pull the paper, if you put it like this, so the water from the glass will not fall down. Why the water from the glass doesn't fall down? Okay. So, okay, before we look up why the water doesn't fall down, can anyone tell me why should the water fall down?
Sir, gravity.
Gravity, sir.
So
Yeah,
gravity.
due to gravity. So
Sir,
gravity is pulling.
even
Yeah.
the
So
atmospheric pressure is going upside.
see, the gravity is pulling it downward. The gravity is pulling the water downward. But as we discussed, that atmospheric pressure exerts in all directions. So can I expect the atmospheric pressure to be pushing this paper upward?
Yes, sir.
Yes. So it is the atmospheric pressure. It is the atmospheric pressure which is pushing this paper upward. Okay. And it is this water which is, it is the gravity which is pulling it downward. If both the forces are equal, this is the gravitational force and this is force due to atmospheric pressure. So if both of them are equal, if the gravitational force and force due to the atmospheric pressure, they are equal to each other, then that is the situation. This will not fall down. Okay. The moment atmospheric pressure decreases, or if you have a fall in the atmospheric pressure, then the water will fall down. Got it? Okay. So shall I tell you some more example? Yes.
Sir, I have a doubt. How can so the inverted glass, the water from the inverted glass will sometimes stay in the glass and sometimes it will fall down.
Mhm. Okay, so you say that sometimes it fall down and sometimes it doesn't fall down. Okay. So see here, if your glass is just straight and if you slide this, if you move this towards a slide such that there is no air space is created. If you have any air space created, so the air will be able to enter inside the glass, and when air enters inside the glass, it will push the water downward. Okay, so it depends on your neatness of work, how neatly you can perform the trick.
Okay, sir.
Okay, uh, then there are different other things also you might have observed.
Sir,
Even if
then
you
we
take
remove the paper, it will fall down, right?
the way you remove, it depends. Okay,
Sir, in
if
the
you
glass,
are,
sir, in the
yes,
glass, when we rotate our shoulder, uh, when we rotate our shoulder with the glass in our hand, the water from the glass won't fall when it is upset. When it is
okay,
upset.
okay, just think of a water bottle. When you try to empty a water bottle, so what happens when you empty a water bottle? Do you see bubbles rising up in the water bottle?
Yes, sir.
Yes, sir.
So why do we see water bubbles rising up and then only water coming down?
So because the air goes up
Because
and
the
pushing the
Because
water
air
down.
is up.
Yes.
in the
So
air
when
pushing,
air is pushing the water, so eventually, if suppose you are able to cover it in such a way that you do not allow any air to go inside it. So if you do not allow any air to go inside it, no amount of water will come outside it. Okay. You must have seen some. Okay, just I'll
Sir,
show you one more. Yes.
sir, I have one doubt. I don't know if it is related to atmospheric pressure, but I wanna ask this. Like a candle is blown out when you put like there's a bowl of water and
Mhm.
candle is kept inside it, and and you light the candle up and you put a glass over it. Is this and the candle is blown out?
Okay, okay. So the water will rise up. That is what you want to say?
Yes, sir. Like, is this related to the atmospheric pressure or
Yeah,
anything?
it's
How
not
is
the
the candle blown
atmospheric
out?
pressure. Okay, it's not the atmospheric pressure, but yeah, it's atmospheric pressure as well as the pressure both are working here. Okay, see what happens. This is the trick you are calling of. Uh, you have a tub and this tub is filled with water. Okay, so this tub is filled with water and you light up a candle over here. This you say, suppose you have a candle and you place a candle over here inside it. The candle is lightened up. So you light up the candle is lightened up. Now you place an inverted glass. This is what you are saying. You
Yes,
place an
yes.
inverted glass over it. So what you will observe that when the oxygen inside this glass finishes up, so the candle will extinguish, right? This is the first point. The
Yes, sir.
candle will extinguish, and when the candle extinguishes, so you will see that water inside this glass rises up.
Yes, sir.
Yes. So see what happens when the candle was burning. When this candle was
Could you say
burning,
what why you explain? So
okay. See, you have a tub containing. Okay, let me take a picture. Maybe you will be able to get it well. Let me see. I think if I'm able to get this picture, this is what you are talking about. Glass candle in water. Yeah, this is the trick I think she is talking of.
Yes, sir.
Yes. So I think everyone should pay attention because it's a big magic. You can do it at your home. You will be surprised to see the result. Okay. So how it actually works over here? You have put some water in a plate and you put a candle inside it. You can see a burning candle is placed inside it
yes,
and the inverted glass is placed over it. So see what happens when the candle is glowing, the air inside the glass becomes hot. So here we have hot air. Inside this we have hot air. Okay. And do we know that hot air means a low pressure? Yes.
Yes, sir.
If you have a hot air,
Yes,
it
sir.
means low pressure.
Yes, sir.
Okay. So outside you have atmospheric pressure where here you have the atmospheric pressure. So due to the atmospheric pressure is constantly pushing this water. Okay. So atmospheric pressure is pushing this water, and when you have low pressure, when the candle extinguishes, so the pressure here is low, you have very less amount of air inside this. So here you have a small amount of air. Now, since most of the space inside the glass is empty, so there is only way for the water to move is to move inside. Okay. So all the water from this, it will move up inside the glass. Okay. Since fluids move from a region of high pressure to a region of low pressure, so here water will move from the plate into the glass. Got it? Anyone who didn't understood this activity? Okay, let me try to show you how it happens. Maybe if it is available, so I'll show you. Okay, see this should explain you what happens. Uh, no, it's not working here. Just give me 1 minute. I should be able to get one.
Sir, you can keep the result pictures as the rising water and balloon.
Yeah.
The rising water and balloon section, you can keep that one, sir. That's a video.
Yeah. So see here, in this one, once the candle will extinguish, you will observe water to rise up. But I think even here also it doesn't. So you can look for the various.
Sir, the red flag one is a video, sir.
Yeah, you can play the video. You can search for it. You can play the video. That's up to you. Got it? So you can,
so
or
like
you can do it even.
doubts.
Yes.
Sir, like today I need to have the physics test, but today we have a holiday, so tomorrow my physics ma'am may keep a test sir, during the, like regarding the numerical questions.
Do you have your physics test also? The
Yes,
test
sir, I
will be
have.
on Saturday. Your test will be on Saturday. Whatever test you will have, the test will be on Saturday.
Yes, sir. Like in school, I have the test of numericals. So could you explain a question, sir?
We did a few questions, I think, last week. So I'm just adding a question over here, which you can do for your practice. For example, the elephant one you did. I think that was the question for from your side only.
The
The
girl, sir,
question.
the girl, what's elephant?
Yeah,
Yes.
yeah, the girl and the elephant scene. Okay, I will share a few questions in the group. Okay.
Yes.
Okay, bye all of you. See you again in next class.
Thank you, sir.
Bye, sir. Thank you.
Bye.
Thank you, sir.
Okay, bye.